Hello, everyone, and welcome back. My name is Rafaela, and I'm the tutorial coordinator here at Architecture Hunter. It's great to see you joining us again as we continue our webinar week. Yesterday, we officially kicked off this special week of conversations, and today we move forward with our second session. For those who are joining us for the first time today, welcome. This week is a part of our 2026 webinar program and brings together a series of discussions that look at architecture from multiple perspectives, from social impact and public space to technology, construction, management, and research. Today's theme is Shape the Future, Innovations in Construction. In this session, we'll discuss how innovation is transforming the way we design and build with two special guests. And before we begin, just a quick reminder, please feel free to send your questions through the Q&A tab throughout the presentations. After each talk, we'll have a live Q&A moderated by Amanda Ferber, founder and editor-in-chief of Architecture Hunter. To begin today's session, it's my pleasure to introduce our first speaker, Lapo Naldoni, member of the R&D department at Mario Cucinella Architects. Lapo is a building engineer and architect trained at the University of Bologna, where his research focused on robotic fabrication and mud-based construction systems. Today, at Mario Cucinella's R&D unit, he works on experimental projects that explore the use of advanced technologies and natural materials, helping bridge research, innovation, and architectural practice across international projects and competitions. So please join me in welcoming Lapo.
Hello, good morning to everyone.
Hi.
Thank you for the introduction. So let me share my screen. Okay. Can you see my screen? Is fine?
Yes, it is.
Perfect, thank you. So let me start with some words about our office, Mario Cucinella Architects. The office was founded by Mario Cucinella in 1992 in Paris. And after a few years in Paris, the office moved to Bologna. And today we have two offices, one based in Bologna and one in Milan with more than 100 architects. But we want, I want to say that we are not just architects, because inside the office we have multiple disciplinarity people, because we start from architecture, but we go into engineering. We have expert in physical model production. We have expert in 3D printing like me. We have researcher. We have storyteller. And so we are in between a lot of different topics, because we strongly believe that architecture today is a complex system and a complex dialogue between different issues, different potential, and so different people. But what we strongly believe is that when we design for people, we need to know that we are influencing the life of people. So we strongly believe that if we design something with a real beautiful, with a beautiful approach, we can really change the life of people that will use this building. For this reason, the architect Mario Cucinella, a couple of years ago, started speaking about creative empathy, because when we approach a new place, we don't want to speak only about sustainability, but we prefer to having this kind of dialogue between all the aspects that are composing the environment of the architecture, starting from the people that will use the building, the owners that are asking for the building, the nature around the building, the surrounding, the neighborhood of the building, and of course, all the weather and climatic condition of the region where we are. So when we spoke about sustainability, it is crucial to understand that sustainability is not just a topic, is a very large amount of different discipline. And in that case, now we have this building that we design in Africa. And what is nice to see is that the shape of the building is designed in order to help the people that will build the building in order to have a very simple system in terms of climatic control. And of course, in the buildability of the building, because the building itself is just made of two materials: concrete, reinforced concrete, and glass. Nothing more, so no shading system, because the structure itself is the shading system of the building. So what we think is that we can redefine the beauty of our time by putting together sustainability, so all the system that we need in order to have a sustainable building, and the system that we use for our buildings. All those is inside the sustainability development goal. So we have a very strong requirement from our nations, and the goals are really complicated to be reached. So we know that we have very strong challenges, and we try to do our best in order to reach as much as possible in all the angle, all those target. And what is relevant for us as engineer and architect is that we are responsible for a large amount of the use of energy, and of course for the production of CO2 related to the production of materials and the use of the buildings. Usually inside the R&D department, when we start to discuss about a building, we know that when we decide the strategy to build and to design our building, usually we focus our attention on the operational phase. But what is crucial is to know that we are just speaking about the 50% of the total amount of energy, so of CO2 emission that we are considering. Because all the other part of emission of CO2 are related to very short amount of time: the material production and the construction phase. So in these 2 years, we have more or less, if we are speaking about an office building, in this initial phase, we will spend more or less 47% of the total amount of CO2 emitted. So it's really important to decide a design strategy in order to use material with a very low CO2 embedded, and find the strategy to use the material as better as we can in order to reduce the stress on the material and the need of extra material. The last part, the 3% that you can see in the end of life, is a quite important phase, not only for the CO2 that we can emit, but more for what we can do with this material when we dismantle the building. So at the end of life of the building, if we design since the beginning with the idea of reuse our building, we can save a lot of material. And of course, all the data that I show to you are related to the current, to the state of art. But if we consider that the human population is growing and growing, is crucial to find a new way to build building in order to reduce and to change the direction of this growing curve. For this reason, since the beginning, inside the office, inside the Mario Cucinella Architects, we have a department of research and development where I am in. So the focus of the team is to support the architect and the engineer inside the office in order to find the best strategy to create a strong concept in the architecture since the beginning. Of course, everything is done with really culturally rooted ideas. So as the architect usually said, the future is a travel in the past, is a journey in the past. And I mean, every time we try to take the best from the past in order to have a good idea for the future. Uh, of course, this is not only, we have not just this mention. We work a lot in terms of environmental studies, so we help the teams in order to find the best strategies in order to control the environment that we have around our buildings. So in that sense, in our office, we can say that the research inform projects. So with the research, we inform our colleagues about new technologies, a new approach, and the project inspire us in order to develop new research for the next steps. Let me start now with some projects that we develop on 3D printing side. So a technology that in the last 10 years is really, is really under the lens, of the attention around the world. So the office started at the end of 2019 to discuss with 3D Wasp, an Italian company that developed 3D printers. We started to discuss the possibility of put the effort of 3D Wasp and MCA together in order to develop a project that can show the limit, so the upper target of the 3D printing at the time. So for this reason, we started by taking in consideration all the ideas that at the time were related to the use of 3D printing. So reducing the building, reducing the buildability time, reducing the cost of the building phase, having more flexibility in terms of designing, reducing the waste. So if you imagine to put the material only where is needed, you can reduce a lot the amount of waste that you produce in the building phase. And of course, reducing the emission and reducing the injuries related to the building site. For this reason, I mean, at the time when we spoke with researcher and with companies, everyone was absolutely was believed that 3D printing was the technology for the future, of course, because all those data was amazing. Everything was showing that it will be the perfect technology for the future. Since the beginning in the office, the idea was to increase the potential technologies for architecture, because we believe that it's not possible to have one technology for everything. Um, Usually now it's better to have a sort of biodiversity in terms of technologies in order to have multiple kind of answer to different demand. So we start and try to understand how is better to use 3D printing in architecture. And to do this, we, as I mentioned, we started from the past. So we try to take in consideration all the architecture done in the past without the use of blueprints. And this is the biggest difference between a traditional architecture of today and what we can do with 3D printing. Because with 3D printing, we can do stuff that are really similar to what you can see in this slide. Basically, the main difference is that usually as architect or engineer, we build drawings. But in that case, people don't need drawings to build those buildings, because everything is transmitted by words, no? So the father speak with the son about how to build the house or how to build the wall. or how to build a roof. So everything is transmitted like inside a TXT file that we can fill with information for the printer and save as a G-code file and reproduce it. So the main difference is that as architect or engineer, we can directly control the machine as what happened with the master builder in those kind of building sites of the past. And from this inspiration, we decided to start imagining how could be the use of 3D printing with natural material like soil. So we imagine together with the student of the Master of Sustainability of the office, SOS, we started imagining this kind of diagram in order to understand and to design a diagrammatic architecture that can be adapted in different locations. So started from who will be the user of the building, the needs, the numbers of people that will use the building, where. So by taking in consideration the location, we take in consideration the climate, the materials, the resources that we can find. And with these, we develop together with the students the strategies. And in that case, every time we try to push the students in order to develop a bottom-up system. So we don't want to start from the master plan and arrive into the technological side of the building, but we start from the walls that we can produce with the local resources. And with this kind of wood wall, we design the final shape of the building. And with the shape of the building that we have, we design the master plan. No? So it's not top down, but bottom up from the wall to the master plan. And in that sense, we started discussing with Mario Cucinella in order to understand not just a building, but a sort of ecosystem entirely 3D printed. So we decided to test this algorithm with the students in 4 different locations. In the cold, in the temperate, in the hot arid, and in the hot humid weather. And you can see here a slide with the 4 different proposals designed from the students. Of course, we decide to develop the first mock-up based on the Bologna case study. And here you can see the different walls that a printer can produce with the same material, because starting from the exact same paste, printable paste, you can decide the amount of ventilation spaces, the amount of insulation spaces, the amount of structural spaces. So in that sense, you can change the shape in order to solve different kind of issues that you can find in your location. And in the case study, in the case of Bologna, we started with the primitive surface that the office designed together with the engineer studio. And with this shape, we start analyze the shape and decide to adapt this kind of corrugation that we use for 2 reasons. Increase the ventilation, the natural ventilation along the wall, and reduce the heating effect on the surfaces, because those kind of corrugation help in a sort of self-shading, like in the succulent plant, in order to reduce the effect on the sun on the surfaces. So here you can see a recap of all the different technology embedded in the skin of Tekla. It's nice to spoke about the skin because it's really similar to what happened in a biological skin, because everything is interconnected. So we use the wall not only as a wall, but as a system to protect the people inside the wall. Here you can see one of the first render designed by the students. And here we focus our attention on all the parts that are not printed. As I mentioned, we tried to print as much as possible. This is the reason why Tekla have no roof, but Tekla is a dome. But for practical reason, you can understand that producing table, producing chair, and all the furniture for the inside is more effective if it is done with wood. Same for windows and roof that are made of wood and glass. So everything was designed in order to be collected and shipped inside a 20-foot container. And you can imagine that in the future, when you want to dismantle the building, you can just remove all these technological part, and the build itself remain a sort of an hill of soil. And as a matter of fact, you can see this image where we try to explain what happened if you remove the technological part from the building. In this slide, you can see the work that we have done together with Mapei, our partner for the materials, in order to arrive to a printable paste. At the beginning, we started together with WASP in order to reduce the amount of water inside the paste, in order to reduce the shrinkage of the material. But we understand quite fast that this material had a lot of problem in terms of adhesion, one layer with the other, and pumpability inside the machinery. So the pumpability was not perfect, so a lot of corrosion inside the pump due to the stiffness of the material. So we decided to change the mix and starting add silica sand in order to reduce the shrinkage but have a more fluid paste during the printing. So with this printable paste, we started work with Milan Engineering, our consultant for the engineering part. And we decided to use a structural part, only the blue part, and the white part that you can see on the left are just for the insulation and the ventilation of the wall. On the right, you can see how we change from the bottom to the top the amount of material inside the wall in order to reduce the weight of the wall. I mean, the material was earth, so we need to find strategy in order to reduce the stress on the material. Here you can see a simulation, an analysis that we made in order to understand during the construction phase the stability of the wall. Because as you can imagine, when the domes are closed, are so stable, but at the beginning it was an open wall, so the stability was not perfect. So we perform to be sure about the stability of the system. We perform this test, and with those results, we understand where to add some support, some wood support, in order to help us to have a more safe building site. Here we have a video of the construction phase of Tekla. As you can see, to build Tekla, WASP decided to use two printers. So the system that print Tekla was composed of two printers that works together in order to avoid collision and reduce the printing time. So no one nozzle, but multiple nozzle in order to reduce the amount of time. We are speaking about something like 250 hours of building site, of course, split in different weeks because of it was a prototype, and the machinery was a prototype, so everything was tested for the first time in this project. As you can see here, you can see the ventilation part in the outside and the infill part for the insulation in the inner part of the wall. And in this time lapse, you can see that everything was printed and realized across August and September 2020. So it was during the COVID, so the best and the simplest time to have a research project, but we try to do our best in order to arrive and person 3D printing construction. 3D printed construction. Okay. And here we have some photo about the end of the building site. And here you can see some photos about the end of the construction with the lighting system, the doors, and the windows. As I mentioned, we tried to use just earth, glass, and wood, or recycled material, as in the case of the furniture that you can see here. And as a sort of symbolic furniture, we add this nature, this tree, in the middle of the living room of Tekla. Those are just some image of the interior. But this is not the only project designed from the office for 3D printing. As I mentioned, Tekla was the first stage, but we understand quite fast that was not so easy to have every time a building site that we can use with on-site machinery. Those are some data, as a sort of recap of what I mentioned. So 2 crane to machine, 200 hours of printing, a lot of G codes, kilometers of extrusion, 60 cubic meter of material, a lot of energy to use the machinery in the building site. So and moreover, not every time is possible to set up a machinery in the building site. Sometimes happens that you have building site where it's not possible to transport inside the machine. You have no space for the machine. Or in other case, for example, you haven't a lot of time in the building site for the machine. So in sometimes it's better to have option to use the same technology for the speed, for the costs, for the injuries. So use the same technology, 3D printing, but not on site. So inside the office, we said, okay, we are architects. So which is the strategy in order to use 3D printing to do something like Tekla, or I mean, to do an architecture in this time. So of course, the first idea was to say, okay, we can split the dome and assemble the part of the domes. But as you can see in this slide, the joint design becomes the more visible part of our building. So it drastically changed the aesthetical approach of our building. So we started to try to understand how it is composed a 3D printed material. As you can see in this slide, a 3D printed material is made of the infill. And when you spoke about the infill, you need to know those kind of geometries, in this case, an honeycomb. And you need to consider that you can change the amount of the infill of your material. And of course, the geometry of your infill. So in that sense, we decided to say, okay, but if we remove the external shell, if we remove the dress, the skin of our building, what happens to our building? It became something more complex, but something that we can use in order to arrive into into blocks that we can assemble, dry assemble, and use the joining part of those blocks as an aesthetical system for our building. In that sense, we started by experimenting with different kind of blocks, and we are arriving to use this hexagonal block with 4 windows that we use in order to to interlock 4 blocks at the lower layer. So we designed this system that became from the Cairo Pentagon, and we decided to develop these blocks with clay, with ceramic. Why ceramic? Because it's really strong and it is really fast, and it is a material from the past that you can reuse an infinite number of time. So in a blink of an eye, we designed these blocks in 3D, and we produce with Fluente some mock-up test at 1 to 3, and we redesign at the full scale those blocks, and we test with stoneware, with recycled stoneware. We test the system. So we print with raw clay, and we fire inside the kiln this clay. We fire this clay around 1200 Celsius degrees, and we obtain these kind of really strong blocks. The first moment to test the system was together with Roca, a very big company, a very big player of the sanitary ceramic. And we decided together to use this system in order to speak about a very big innovation that they represent in 2024 at the Milano Design Week. So together with the team of Roca, we want to speak about the first electrical kiln for the production of ceramic, industrial ceramic. So it is a tunnel kiln entirely powered with electrical energy. So a relevant point of this kind of kiln is the perfect control of the temperature curve inside the kiln. For this reason, we decided to use our material, our blocks, in order to materialize this curve and to use this curve as a room, as an installation inside the Milan Design Week. So as you can see here, we materialize in the corner inside the statale that we have for the installation, and we realize these sort of experimental and sensorial space where you can understand the firing of the ceramic with different temperatures. So starting from the blue, we arrive into the red in the center, and we go back into the blue. And we materialize this installation with 1,200 blocks. Here you can see the final results. And what happens with this installation is that we use the same blocks 3 different times in different event of Roca. So we reuse the same material, and we transport the material across Europe for a different event and installation. So this is something really nice for us because it represents the possibility of reuse material and installation, especially in a case like this, where usually you produce the installation, you use the installation for 1 week, and you dismantle and destroy the installation. In that case, everything was moved with a very high attention because we reuse a lot of time the same material. The second experiment that we have done in terms of off-site printing is a very nice project and very challenging project because it was designed for the island of San Servolo in Venice. So inside the laguna of Venice. And what happens here is that the client asked us to design a project in order to change the use of the football pitch that you can see on the bottom of the island, because it's a part of the island that is unused, and they want to find a way to use this space for cultural event, for theater, ballet, so for all these potential outdoor event that they have during the summer. And they ask for something of innovative to be built inside the island. So, we tried to find a way to move the nature from the surrounding on the football pitch into the football pitch. So starting from the shape of the amphitheater, we try to move and to obtain something more fluid, something more usable and more open to the outside, and of course open to the island in front of San Servolo with a very beautiful church and a very beautiful tower. So as you can see, we decided to locate the theater in this portion of the football pitch. That was the ones with the most beautiful view on the Laguna. And here you can see that we materialize everything with something like 900 blocks. But in that case, we are inside the Laguna and move all the blocks from Italy into the island of San Servolo is really complex. I mean, the transport, the logistic inside the Laguna of Venice is really complicated. So for this reason, we decided to use a different approach. We decided to work with Erratic, an Italian company that produced 3D printers, and we decided to use this small robot that is movable. So we decided to move the robot on the island, to move the pumping system on the island, and to produce all the materials that we need on the island. So as you can see, we started test the system on the island, and we designed this shape of the blocks in order to help the stability of the material during the process. So the limitation of those blocks was the weight, because everything must be assembled by hand without machinery. And the second point is that we use lime-based mortar. So the lime during the process is really unstable, and to increase the stability of this material, we designed these waved blocks, and that all those waves help the stability during the printing process. So we use now an issue in order to create a design. Here you can see one of the first assembling tests, considering that for this system, we use a family of 47 different blocks. And here you can see, I mean, our warehouse, that was the football pitch, some operational moment. And here you can see the different stages of curing of the blocks. So the darker are the freshest, and the whiter are the more aged. And going back into the renders, this was a render, and this was a building site moment. And here you can see the final result of the installation in the day and in the night with the lighting system inside the green part. Here you can see now the final results with the view, the back is the lagoon. So we tried to design this system in order to, give to this part of the island a most suitable use. The last project that I want to show to you today is an installation that we have done for the Artesella park. Artesella is an art park in the north of Italy, in the Alpi, close to Trento. And basically, the idea was to work inside this place that was strongly, damaged from the Via storm a couple of years ago. And so we decided to design something that can, give to people the idea of nature can protect us and not only destroy our environment. Nature is not just the storm. Nature is something more. Is something that we need to live with. And so we decided to design something that grow from the earth and can take inside people in order to take rest and take a look into the Artesella park. And for this project, we decided to work with two companies of this region. One is Erratic, and the second one is Calchera San Giorgio. Calchera San Giorgio is a very ancient company that works only with natural materials. They take inspiration from the Romans material, and they reproduce the material of the Renaissance and the Italian history. So with they, we decided to do something really similar to Tekla. So we started putting together local materials in order to find a way to use a lime binder in order to put together the tonalite and other materials, other stones of this region. So Calchera San Giorgio worked together with the Polytechnic of Milan in order to arrive into a suitable mix. And as MCA, we designed this installation made of 50 different blocks with 3 different coloration that are representing the color of the local materials. And we assemble all the blocks together by using local manpower. So we try to use as much as possible the local sources, the local energy, with a global approach. Here I think that we have a video of the process where you can see the robotic arm that is printing with this really precise material based at the 60% of tonalite dell'adamello and the 30% of lime and other natural additive. And here you can see the installation where we work together as MCA and Erratic, Calchera San Giorgio, and the local manpower in order to interlock all the blocks without the use of any kind of glue. So everything is dry assembled and everything could be disassembled just by removing the blocks. Those are some pictures of the final results of the Artesella installation called discrete landscape. As you can see, one of the idea is to add the nature inside the blocks, and maybe in some years the installation will become something of the nature. So now we are designing not against but with nature. Those are some details of the blocks and the different colors that are really close to the colors of the stone of these. You can see the color of the stone because the stone are inside the blocks, so it's so similar. And this is a view from the bottom, from the top, sorry. Okay, this was the last project. I think that is more or less okay, the timing. So thank you for the attention, and yeah.
Hi, Lapo. Thank you
Hi.
so much. Hi, thank you so much for the presentation. It was amazing. I'm actually a really big fan of Tekla, and I've always wanted to hear you guys talking about it, and it's so interesting to learn a bit more about it. Thank you so much. It was an amazing presentation. Well, because we still have another session, we're gonna have just a little time for the Q&A. So unfortunately, I'm not going to be able to select all the questions, guys. I'm sorry. But we have a question here from Muskan Gupta. He asks you, hi, are there groundworks made from 3D printing workable against termite, moisture, and other such soil-related risks?
Yeah, no, not all the soil are suitable. We can consider that 1/3 of the human population live in earth house. So there are a lot of places where earth is suitable. The termite are not a problem in that case. Of course, we had lime inside the mix. As a binder, we use lime, and it helped a lot in order to stabilize the soil under the effect of animals and other, I mean, living potential vegetation or stuff like that. So the use of lime, that is a natural material that absorbs CO2 to become stronger, help a lot into control all the biological aspect of the material. So it's possible to stabilize a little bit, but I mean, not everywhere it's possible to use the local soil.
Yeah, makes sense. Another question from Aurelie Devi. Hello, I want to ask, considering the current limitations of transporting and deploying the printing machine in remote or dense urban areas, do you see Tekla as being solely for permanent residential communities, or does it have the potential to be suitable for emergency housing, for example?
Yeah, when we start discussing with the students about Tekla, we started with the emergency. Was one of the first idea. I mean, of course, the limitation of 3D printing in this moment is the density. You cannot build building for high density at the moment. The only chance that you have to use 3D printing for high density is by using the offsite. So to creating module that you can assemble at arrive at a 5, 7, 8 floor. But in the case of Tekla, yes, I mean, is fine for remote if the soil is suitable in the case of Tekla. Otherwise, I mean, you need to find strategy as more or less what I showed in the case of Artesella, where we were lucky and we find a company that is 5 kilometers from Artesella, and they work only with local materials. So you can use different materials, not only soil, and transport just the printer, of course, in order to build low density village, low density, I mean, place.
And well, Dr. Rim Meziani asks, thank you for the interesting presentation. Have you tested these materials to heat and humidity?
Yes. At the time with WASP, we tested another project that they have with the same material, a sort of mock-up of the wall, and it works perfectly. More or less, the U value is 0.40, 0.45. So, I mean, the thermal mass of Tekla is really huge because the dimension of the wall is something like 60 centimeter. So the thermal mass is really good. Of course, thanks to 3D printing, there is a lot of air inside. So it works well in both conditions, not only on hot and humid, but mostly in cold. So it works.
Yeah. And like in the images that you show in the beginning of a presentation of more like rough construction, clearly it was also in very hot climate, right? So it's almost the same. So yeah.
What I mentioned is that thanks to 3D printing, you can change the density of your wall. So by move these, now you can adapt the system into different configuration.
Yeah. And just final question, because it's very interesting. I wonder that too, from Karen. Hey, are 3D printers suitable for construction in seismic regions?
Yes, I mean, for Tekla, we started discussing about that with Milan, the engineering studio. And basically, the problem of earthquake usually is for multiple story building. In that case, we are speaking about one story building, and the shape itself is self-resistant. So it's quite easy to have something strong if you are at one floor. All the problems becomes when you are at 2, 3, 4, 5 floor. But in the case of Tekla, I mean, the maximum height was 4.8 meter. So no real problem in terms of earthquake. The biggest solicitation that we test was related to the wind. Was higher the stress of the wind than the stress of the earthquake.
Could you say that in some way it could be even more interesting, like for earthquakes when you design with Tekla, or not necessarily?
Not
Is it more?
necessarily. I mean,
Okay.
it was something that we considered.
Okay. Well, we don't have time for many more questions, but thank you, Lapo, so much for your presentation and for your time. It was amazing.
Thank you so much. See you soon.
See you soon.
Thank you so much, Lapo, for sharing all your research with us today. We really appreciate you taking the time to open today's session. And now it's time to introduce our second guest of the day, Elora Hardy. She's the founder and creative director of IBUKU. Elora leads one of the most influential studios working with nature-integrated architecture, and through IBUKU, she has designed over 200 innovative structures, redefining materiality and spatial experience. Her work has received international recognition from institutions such as the Royal Society, and as a TED speaker, she has shared her ideas globally and at venues including the MIT, the World Government Summit, and the US Green Building Council. So please join me in welcoming Elora.
Hi. My screen sharing doesn't seem to be turned on.
We can see your screen now.
Great. Hi, everyone. I'm Elora, joining you from Bali. And you might have seen our fairy tale-like structures and wonder what kind of magic is going on in Bali. And today I want to share a little bit about what happens beyond all of that. My examples are in bamboo and in our innovations with this material, but the real story is about reimagining the design process. So this is a 6-story bespoke home here in Bali. We built this 15 years ago, entirely from bamboo. It's called Sharma Springs. The living room overlooks the valley from the 4th floor. And back in 2010, when I completed this house, we really broke the mold of what's possible with this material. I was just beginning to grasp how far there is to go, how much there is left to learn. So we ask ourselves, if we've never seen a building before, what would we build? It can get hot in the tropics, so making these big curving roofs naturally catch the breezes. That's intuitive. And some of the rooms do have tall windows to keep the air conditioning in and keep the bugs out. Some rooms we actually leave open on purpose to have the creativity of form. And in this case, we just air conditioned the bed. We do have necessary luxuries like bathrooms. This is a powder room. It's a basket. It's in the corner of a living room. And I have to tell you, some people do actually hesitate to use it. We hadn't quite figured out our acoustic insulation at this point. And we honestly have made a few too many things out of bamboo. There are lots of things that we've learned and some things that we've given up on. I don't make hand-made bamboo toilet seats or tank covers anymore. But the one thing that I have learned is that bamboo will treat you well if you use it right. So because we're on a new frontier, that means we have to understand the material that we're working with to really get to know it, to listen for how to work with it on both a practical and an intuitive level. Here we are doing tests in parallel to construction. These big spans of the arc at Green School Bali, they taught us a lot about limits, deflection, joint behavior, and about working with engineers from day one in the concepting of a project. So we push the form, but we listen for where bamboo is in the comfort zone and where it needs support. This is the arc at Green School in Bali, built at 2021, and it was a leap into the future of possibilities for natural materials. Our engineers, Atelier 1, they won the Supreme Award for the Institute of Structural Engineers for this building in the UK that year, not just for a sustainable material for bamboo or for timber, but just in general, the award for the year. Inside, this building feels more like a body than most buildings you've been in. And the thing is about bamboo that it does sequester a huge amount of carbon as it grows. It grows incredibly quickly, absorbing CO2. When we turn it into long-lasting buildings, that carbon can stay stored in the structure. And of course, it's sequestration minus everything humans do to it. So building with a locally grown poles as we have has a much lower embodied carbon than the comparable reinforced concrete or steel frames. And back in 2000, 5 when my father and stepmother began building this school called the Green School in Bali without any building experience in their past. It made no sense to me until I saw it. That's my dad. He's the one who got me into building with bamboo, and he's standing in a clump of Dendrocalamus asper niger that he planted just 7 years before this photo. And each year, this clump, it sends up a new generation of shoots. That shoot, we watched it grow just 3 meters, grow a meter in 3 days that week. So we're talking about sustainable timber in 3 years. We have harvested poles from hundreds of family-owned clumps. Patung, as we call it. It's really long, up to 18 meters of usable length, but try getting that truck down the mountain. It's also very strong. There's tensile strength that can be compared to steel and compressive strength to concrete. And it has a really impressive strength profile. It's also hollow. It's lightweight, light enough to be lifted by just a few people. And so when they chose bamboo to build the Green School, it was because they had named the school Green School, and they decided that a sustainable timber wasn't well developed in the region. You couldn't have credible sourcing for it, and reclaimed timber just felt like reusing something from the past instead of taking a stand for the future. So they saw bamboo as the right material because it was a promise to the kids that it's one material that they can grow enough of and that they will not run out of. The problem is no one had really built anything higher than 1 stories with bamboo or in any curving form. And when I saw what they did in just the first year, it did seem to make perfect sense. Beyond being sustainable, being a little bit less bad, bamboo really embodies goodness. And when I saw this, I thought, actually, why hasn't this happened sooner? And what can we do next? With this material, you really can be light on the land. I'm still mesmerized by the simple beauty of these foundation points. These are huge rocks on which multiple poles of bamboo each stand. They're the moisture barrier. So along with the original builders of Green School, I founded IBUKU. Ibu means mother and ku means mine, so it represents my Mother Earth. At IBUKU, we're a team of artisans, architects, designers working together with Bamboo Pure. It's an artisan construction workshop. And what we've done together is really to create a new way of building. Over the past 15 years, we have built over 200 unique structures. Some of my favorite ones I designed at Bamboo Inda, our family hotel. Please come visit us in Bali. You can come swim in the spring water in the jungle, or stay in our newest guest room. This is New Moon, where you can jump out of the window into a completely natural spring-fed plunge pool. We've just added a riverside restaurant. Here it is at concept sketch stage. Here it is complete. It's nestled among the rice fields. And while you're there, you can also see Green School. We keep building classrooms every few years there. And this is the new makerspace, which will open later this year. So continuing the innovative system of grid shell that we developed for the ARC at Green School, we created Lumi Shala at Alchemy Yoga Center. It features this grid shell system, which is really a whole different evolution from what had ever been done before in bamboo. And in nearby Malaysia, where there are some of the strongest typhoons in the world, you can also see a giant bamboo building. And in this case, we chose a combination of an elegant steel spine engineered for those typhoons, and asking the bamboo to be doing everything structurally would have just been a lot of bamboo. It's possible, but it wouldn't have been an elegant form. And so we designed the combination of materials to be able to use each material wisely and to develop the possibilities in this part of the world with a way of building in bamboo that was mostly unfamiliar to them. We've also worked as far away as in Panama. In Panama, we featured these tall timber stilts. These are trees that are reclaimed from underwater in the Panama Canal. This was built during COVID without us ever going to site. So we had to use very simple bamboo techniques. And there was a team who locally sourced bamboo from the region and had some limited skills of carpentry with bamboo. So we developed just the interiors and the very top floor with bamboo, because the bamboo needs to be protected from weathering. So the roof overhanging just far enough to protect the top level of columns from the rain. Now, what we're doing, it's not entirely new, from simple huts to elaborate bridges like this one in Java, sometime 100 years ago or so. Bamboo has actually been in use across the tropical regions of the world for literally probably hundreds of thousands of years, if not more. There are islands and even continents that were first reached by bamboo rafts. But unprotected bamboo, it does weather. Untreated bamboo gets eaten to dust. And that is why, until recently, it was almost impossible to reliably protect bamboo from insects. And just about everything that was ever built out of bamboo in history is gone. And that is why most people, especially in Asia, think that you couldn't be poor enough or rural enough to actually want to live in a bamboo house. And so we thought, what will it take to change their minds, to convince people that bamboo is worth building with, much less worth aspiring to? Because if you treat it properly, if you design with it carefully, engineer it, a bamboo structure can absolutely last a lifetime. The thing that we have found is our path, our journey, our role is to build something extraordinary out of it, to really inspire people to go beyond what is necessary. And we're able to do this in large part because Balinese culture fosters craftsmanship. It values the artisan. And Balinese village men have been working with bamboo for more temporary structures to do with ceremonies for many, many, many generations. And they also have a lot of skill in timber. So to combine those and to teach them new techniques and collaborate with engineers and architects to create this real new adventurous generation of outliers in the industry, to be able to create extraordinary things. What we have to always remember when we're building with poles is that they are curving, tapering, hollow poles. No two poles alike, no straight lines. These are not 2x4s, and I confess sometimes I dream of 2x4s. The tried and true, well-crafted formulas and vocabulary of architecture do not apply here. Good thing I don't know those things. I didn't train in architecture. I haven't studied architecture. Therefore, I didn't know the rules to reinvent them, but many of my team did. And together we have been able to look at which traditions and which customs and which common ways of working should be held to and carried forward, and in which ways we want to do things differently and we need to do things differently to achieve the kind of projects that we do. Like many designers, the first thing we do is stand on the land and ask what can belong there. We don't start with a perfect form and then decide to make it. We start with the land, the climate, the people. We ask what should happen here? What are the risks here? What are the possibilities here? What should this building be made of? And the form grows out of that. When we're working with bamboo, we don't always work with bamboo, but when we do, we ask what it's good at, what it wants to become. And before we spend too much time drawing, we also talk to the craftsman, because the kind of designing does not happen on flat paper or behind a flat screen, or even in the 3D beyond the screen. There's a real tangible, visceral part of the process that we hold on to. This is a conversation. We design in real 3D, making scale structural models out of the same material that we'll later use to build the house. Bamboo model making, it is an art. And these, at first, we primarily built from bamboo models and from hand drawings. And now we are increasingly supported by the digital. Even augmented reality is something that we are beginning to be able to use in construction, even though it's not precise, because we are used to operating with a range of tolerance because we're working with natural materials. So now we can be supported in a positive way by the digital, but we always keep pulling back to the analog as well. And we really need to bend the digital to suit our world. We need to plan for the range of tolerance that a natural material needs. And we're always looking philosophically, how do we keep ourselves grounded in reality? So this is the first time, it was in 2021, when we used heavy machinery on site at all. And it was very helpful to lift these arches into place and position them in the way that the engineer required for the strength of the building. Now, when it comes to the interiors, when it comes down to the details, we really consider everything and try to take a fresh perspective. In our world, right angles need to prove their relevance. We welcome them where they're relevant, and very often on these natural landscapes and in the building, once we begin a curving journey, is not. So in this bedroom, we created a pivoted door, pivoted on the center where it can stay balanced. And the visceral experience of just pushing and having the momentum of the door is something that a lot of the residents of this house have commented on and appreciated. This is one of the few places in the house in Sharma Springs, the biggest one that I showed, where we even used glue. It was very purely bamboo at that time. And to reap the selective benefits and work within the constraints of this material, we have really had to push ourselves to find space for something new. It's been a challenge. This room needed a ceiling, and we couldn't bear to put a flat ceiling in this context. So we wove the ceiling together. There were no drawings of this. We created this on site with the craftsmen, planning with their sense of understanding of the material, how to achieve the strength and how to achieve the grace. We tied it together with little tiny bits of multicolored string, and we stretched t-shirt jersey over it and lacquered it. When we work with bamboo in Bali, where we have the skilled craftsmen, it is mostly handmade. This supports livelihoods, education, biodiversity, and we haven't formally measured it, but that's part of the value of the stored carbon. For our first decade of building, we made everything out of these itsy bitsy little splits. I did not even use plywood in the ceilings or in the building or in the insulation, and we did not yet have access to industrially produced bamboo panels either. The structural connections of our early buildings were reinforced by, and still are reinforced by steel joints, by steel pins, but we use a lot of hand-whittled bamboo pins in the process as well. And that there are thousands of pins in each floor, for example, and that is because the bamboo over time, the pin and the plank work together and expand and contract in harmony rather than introducing another element. This floor is made of glossy and durable bamboo skin. You can really feel the texture under bare feet. One of the things that I really find is missing in the industrialized world, in the modernized world, in the minimalist world is texture, is variety, both for the eye to rest on and find relief in, and also for the skin to touch. A floor, how can it affect the way you walk? If it's hard and impermeable, or if it's irregular, how does that affect the footprint that you will ultimately leave on the world, or the way that you walk in the world? And in the past decade, in our footsteps, there have been thousands more bamboo buildings built across Bali, across Indonesia, and many around the world, using our techniques, the innovations, and the craftsmen that we trained. We have built the bamboo industry in just 15 years. On a vernacular tradition, but that vernacular tradition had a very limited palette of linear pole-based bamboo construction, right angles, traditional forms. We have taken it far beyond that. This is a material that was completely associated with poverty and temporary huts and maybe artistic traditional elements that were very short-term and temporal. But in under 2 decades, it has become a new vernacular: houses, schools, hotels. And this has been an extraordinary thing to see. Now bamboo buildings are associated with Bali in general, and people might think that they were the vernacular, but it's been completely invented in the past couple decades, largely based on the collaborations and innovations that we developed for the material. We also teach about bamboo, both the philosophy and the practical construction uses, by welcoming students around the world several times a year to a course that we host in Bali called IBUKU, and it's also available online for smaller stretches of time. And that's been an amazing thing to see the bamboo community grow. When you're starting out with a new material that's really an old material, but you're reinventing it, rebranding it, having a community of people who have the passion to learn from it. But the most extraordinary thing that I hear back from some of these students from around the world is that they say that they didn't just learn about bamboo. It's really about how to have a conversation with the material, how to hold on to being part of nature, and working with materials in a way that hold on to their own personality and keep that sense of identity intact in the material as you play with it to create your own design direction. So that's what we hold on to while we take on projects for clients who want a mixed media palette, as honestly most clients do. Our work is not entirely bamboo. For the past 5 years, our homes are consistently really a mix of materials. This one only has bamboo in the roof. And now when we start a design project, we ask where what material belongs. This connects in with the codes of a certain region, with the durability or longevity based on the form, and what actually changes when you start a project by asking, given this place, these crafts, these codes, this climate emergency in the world, What should this building be made of? And that's where the conversation starts. And then it evolves. We're playing continuously with bamboo innovation, with lots of grid shells, with glulam elements in our buildings. Once we got into engineered or laminated bamboo products, they do still perform better than steel and usually more than concrete on a per strength or per element basis. Bamboo isn't magic, but it's got some really great advantages. And to design with it, you need to understand it, as I think you must with any material. So along with perfectly sealing curved glass windows and a combination of teak and terrazzo walls and floors, this house is going to be magical. For some overseas projects, and for people who want what we do, but in places where bamboo doesn't make sense or isn't allowed to be built with yet, this house is in the woods outside Atlanta, Georgia, and it's mass timber arches by Herring. And for this one, also in the US, we aren't doing any curves at all. It's all straight lines, but also we got away from the right angle. For each project, we start with a conversation with all of the elements that will come together. What we've learned from bamboo is to listen to the personality of a material. This is a site in Albania. It's going to be a 60-room hotel. And our hearts are always coming back to bamboo. It's very hard to make something more beautiful than nature does. There is no arrangement of glulam that can have this character and this personality. So it's not really about the bamboo itself. It's about how we've learned to see and what we've learned to feel through it. In Bali, we've basically spent 15 years proving that you can build castles out of grass. And if we can do that with bamboo in this tiny corner of the tropics, what else is possible? What materials are we still underestimating? What could become the next impossible vernacular in the next decades? This is all just part of a process, part of a journey. And starting from the context, the land, the people, and the supply chains and the carbon story, these are the things that we need to think about as we choose what to build with. If we insisted on only doing things toward the most beautiful, healthy future, we'd remember that being a bit less bad is not enough. We need to do good with materials that will grow back. Thank you.
Hi, Elora.
Hi, Amanda.
Hi, it's so good to see you again. It's been quite some time. Thank you so much for the presentation. It was incredible. I always love hearing you and seeing you talking so passionately about bamboo and all the work you've done. Thank you so much. So I'm gonna start with the Q&A. We have a very interesting question here. Well, working with natural, irregular materials like bamboo must present unique challenges. Can you share an example where these constraints led you to invent a new form or structural solution?
I mean, we just get ourselves into the craziest messes because we are working very often with material that can't be fully tamed. And that we don't want to tame, that we want to unleash something new and possible through it. So there, I mean, like the bathroom that I showed, the powder room, like we had this big open living room and you couldn't just put a box in it. It would look like a porta potty, right? So that was not a bamboo constraint. That was just a design constraint. Like we needed to create a bathroom that could make sense. And so we wove a basket and that felt right. That felt like we were in conversation with the bamboo. But then how do you insulate a basket? And that just has been like that kind of thing has been just these puzzles that we've had to dive into and figure out. It's really complicated when it comes up against conventional expectations. Expectations, for example, a pane of glass is usually flat unless you want to spend a bunch of money and make it curved. And then it's usually still got straight angles on it unless you make a lot of templates. So we end up in trying to fuse these things up against artisanal or natural or naturally grown shapes. And there's a tendency that to achieve perfection, to have control. And you can't have control. You can't have full control. You have to be in a movement, in in a conversation about it. And that's just very confronting as a human in the world today. I don't have a magic wand. I can't just solve these things. And so that the struggle of that, like facing my own need for control, my own like wish to like, and also the clients that setting their expectations, because they also believe that things should be controlled. So this has been a journey.
This is almost like a therapy, I feel. Well, there's another question here. IBUKU's work started in Bali, but has inspired projects around the world. How do you adapt your bamboo-based design strategies to different climates, cultures, and regulatory environments?
Well, some of the regulatory environments preclude the use of bamboo structurally. So then we just try to take what we've learned and think about what materials we do want to work with and how to not just over control them. And in order to create a space where people can feel more at ease and more comfortable, like somatically in our bodies, I don't think we are comfortable physically in spaces that are made of flat, smooth surfaces. So just kind of trying to get us back to something that's viscerally comfortable while still keeping in mind the sense of nostalgia and identity and stylistic preference that we develop over our lifetimes. This is a balancing. But in other countries, there might be, and in some countries around the world, there are bamboo codes, but they might be very connected to a certain kind of shape, a certain vernacular that's very limiting. Even in the US, you can build some things with bamboo, but only in a very certain way with one species of bamboo with a very hard won process to get that approved to be utilized. So it's not as open a process for design. So yeah, in each place, we have to understand the landscape of what's possible in whatever material we use. And we just keep trying to ask dumb questions. We're like, well, can we try to do this? What if we did this? And see where that can take you. Sometimes the simplest innocent questions can unlock something new.
Well, there are two questions about bugs and insects, so I'm gonna select only one because they're almost the same. So Ling Bongjing asks, "Hey from Malaysia, can you elaborate more on how you tackle the issues of bugs and moisture? I've been to a bamboo-themed resort in Malaysia, and they had to constantly use pesticides and replace their bamboo roof shingles as they rot after some time. Does the building in green schools face such issues as well?"
In the thousands of poles of the buildings on Green School and all of the buildings that we've built for the past 20 years, there have been 2 poles that from an early stage building that were ever eaten by the powder post beetle, which is the main pest. And I think that those poles somehow snuck onto site without going through the treatment tank. So there is a reasonably tried and true established, I don't know, 60 or 70-year-old process for treating wood with boron, which is a salt. And that is the basis. That's the only reason we're able to build long-lasting buildings. And if you do that right, you're on a really good track. A lot of people don't do that right, or they skip that step. The next step is you need to protect the bamboo. You need to put it within a structure that has a roof overhang that protects it well enough. Otherwise, it will get weathered, the UV will erode it, and the moisture will come into it from repeated rain contact, and then it will erode. So there are a lot of buildings being built right now in the world that will not last decades. And there are other buildings that will and can because they were done right. If the building is in a very humid place, then there's going to be totally a chance of mold. And that is the same, actually worse, when you have a concrete building because the airflow and the way that the concrete is structured is worse for the mold. So some of these things that we navigate are just typical tropical issues. But if you've got a properly designed building, properly treated building, then it can last for many, many years. The roofing has to be replaced. If you've put bamboo on the bamboo shingles on the roof, you got maybe 5 to 7 years, and it needs to be replaced because it's being exposed to the weather.
Yeah.
So those are the main variables. Yeah. It's really good to mix it with other materials. Like don't use a bamboo roof if you can use something that's longer lasting and to combine.
There is another question also kind of about the roof. Uh, how to make those roofs waterproof? How do you protect the indoors from rain? And this question is from Gaurav Dutta.
So the roofs are always they have a liner. They're like made with some sort of liner. There's a variety of different systems you can use. More recently, we've been using more copper roofs because the copper is much more durable to the weather and it is ultimately recyclable. But the depending on your building style, you could use sort of any kind of roofing. If you want to make a curving roof, then it's limited, slightly more limited. But the bamboo roofs that we did for some time are not bamboo. That's not the waterproofing layer. That's just the top layer for some insulation and for cosmetic reasons. And that part needs to be replaced.
Polkit Singla has a question. Can any type of bamboo be used for construction? And does the location of bamboo origin affects its usability?
We've had engineers who wanted us to test multiple poles of every species we were using from each clump they were being sourced from. So apparently the engineers are concerned that there is a dramatic range of strength even with one species between one clump and another clump and water conditions and the rainy seasons that during its lifetime. So as I said, there always needs to be a range. The engineers have to work with a safe range, and that's because the wall thickness varies, the spacing between the nodes varies, the diameter varies, and the shape of the pole varies. So all of these things mean the engineers need to adjust all their parameters to be quite conservative. As designers, we're very familiar with the sense of like which bamboo poles are stronger and which are weaker. There are some bamboo poles that we don't really use structurally. We use them more decoratively or for interior elements, and others that we rely on structurally. And in Bali, I'm using like 6 or 8 species of bamboo total of the like 100,000 plus type of bamboo in the region and even more in the world. There are so many different species.
So many. I didn't know there were so many.
It complicates things because it's harder to get standards in place and to get codes sorted out and to get engineers to share the data so that more of them know and to get often the burden of the testing, of the engineering testing that's necessary to sign off on the building is on the client for that particular project to be able to achieve that system to do new engineering for it. And that's a bit unusual. So socializing these things and making sure that people are prepared for this if they want to do something new and special is part of the journey.
And I imagine that it requires lots of research, depending on where you're building with, depending on the type of bamboo you're using, because it's not like the same for every type of bamboo, right?
And the kind of research that we have to do is like make new data instead of like looking up existing sources and precedent because there isn't much.
Gurav Duda also wants to know if you can suggest some study materials and books for getting more info on bamboo construction as an architect, and he thanks you for the answer.
I mean, I would go to IBUKU on their website. I think that they list a lot of great resources.
Oh, great. Okay. And Adida also has a very interesting question. When a structure is being erected mostly out of wood or bamboo, I think there will always be a question about fire safety. So, what is a comment on solution about it? And also, how the service like plumbing can be incorporated in the structure? And what about the issues like water leaks and structure getting damp? I think you have already talked about structure getting damp, but the other things I think is still interesting to answer.
In terms of water, I mean, of all of the wild innovations and craftsmanship stretch that we did to achieve the first like dozen houses, the most issues were with plumbing because partly because we were bringing conventional plumbing systems into a slightly shifting flexible structure, and partly because there just wasn't excellent plumbing available at the time for the kind of contractor you could get to come into the jungle and help you with one little house. The the excellent teams would only be there for bigger projects, and we were doing one house at a time. So it just wasn't great quality. So like I found it really ironic and frustrating at the time that like we managed to do so much of the stuff that no one had ever done really well. And then the boring stuff like the plumbing just like was being the Achilles heel. In terms of fire, you've got to relate to it like you would a wooden building. I would hesitate to put all the petrochemicals, whatever kind of chemicals you need to put on it to make it fireproof because of health reasons. And so we keep that in mind in the design process. If we make a multi-story building, we consider how people will get out. And we don't have a lot of walls. No, I'm kidding.
Yeah.
We have, interestingly, it's also connects with in your region whether it's possible to get fire insurance for a bamboo house, which here you can. So there's these are the considerations. But I find that most of the world's designing and all of it has become so focused on liability and risk aversion that it has been so limiting. And the only reason we've been able to make anything new and special and offer some sense of like a new direction to people, we haven't figured it all out perfectly. It's not the perfect solution, but to be able to show and like tangibly like realize buildings that catch people's hearts in a different way, and make people inspired to try new things. That's only possible because the climate here, the landscape here, the way that things are here allowed for that freedom. And the clients that we had were willing to be on that adventure, to be on that outside of that safety net. Not all projects can afford that. Not all people can justify that. But when you have the chance with the people who are up for that, then it can make something new possible that can then have an effect on everything else.
It's been a while, but like I once was in a wood lecture in architecture, and I might be mistaken, but I remember he said something that like actually when it comes to wooden structure, when it comes to fire, it's actually even safer for people to run away because of like the wood actually like burn more controlled. I don't know if this is right or if this is also goes for bamboo, but I heard that and I thought it makes sense actually.
Well, even within the world of wood, there's a really broad range of like the speed of how it burns and how it behaves, and then the different ways you can use it. So it really varies across the spectrum.
Yeah. Oh, okay. Well, I think we ran out of time, but we could do almost all the questions. So thank you so much, Elora, for your time, for the presentation, for answering all the questions. It was great hearing from you again. And thank you again. And thank you also for the audience for staying with us until the end.
Thank you all. Bye.
Bye.
Thank you so much, Amanda, for moderating today's conversations. And a big thank you to both Lapo and Elora for sharing their work and time with us. And before we close, just a quick reminder that our webinar week continues tomorrow. And tomorrow we'll be hosting the theme Narrating Spaces, Management and Strategy with Olivia Argentini. She's the São Paulo office director at Archea Sociati, focusing on management, storytelling, and strategic thinking about architecture offices. And on Friday, we'll wrap up the week with the theme Rethinking Practice, Research and Innovation, featuring 3XN GXN and Neil Leach, co-founder of Digital Features. So thank you all so much for being with us today, and we hope to see you again tomorrow.
Just also another reminder that all our sessions are available on YouTube, the webinar. So if you guys want to watch it again, or if you missed yesterday's webinars, you can watch it on our YouTube channel. Thank you, guys.
Thank you, guys.